Hi everyone, welcome back to the channel. Till now we have discussed descriptive statistics. Now let's go to inferential statistics. So descriptive statistics is used when you have some data and you want to summarize or describe it in order to make some sense of the data. But inferential statistics is where you have two different data sets and you want to compare them to drive a logical conclusion. For example, you want to know if the new drug works against a disease or not, or a new exercise routine is actually reducing the weight, or a new marketing strategy has increased the sales or not. So, exactly how do we use the inferential statistics? The first step is to form a hypothesis. You see, one doesn't go comparing two data sets or more without any aim in the mind. Even if we are comparing simply the weights of population of two different countries, we somewhere want to know which country's population has more weight and which has less weight. Simply said, hypothesis is a conclusion or an inference or a result you expect from comparing the data. So, how do we form a hypothesis? Let's start with a simple example. Suppose you have started a new exercise routine and now you want to know if it affects the weight or not. So, the conclusion you want to draw from the data is that the new routine affects the weight. That becomes your hypothesis. And when you compare data to test your hypothesis, it is known as hypothesis testing. But wait, there is more. In statistics, there are two kinds of hypotheses. One is the null hypothesis, which says that the dataset comparison does not change anything or prove anything new. The other one is termed as alternative or research hypothesis, which, as you might have guessed, argue that the data does prove something new. Null hypothesis is commonly denoted as H0 and alternative hypothesis as H1. Generally, in statistics, we take the null hypothesis as the main argument during the data analysis, and by rejecting the null hypothesis, we prove that our alternative hypothesis that we want to prove is true. So, in the previous example of the exercise routine, null hypothesis will be that the new exercise is not affecting the weight, whereas the alternative hypothesis will be the one where you want to prove that the new exercise routine is affecting the weight. So, if the data comparison rejects the null hypothesis that the new routine is not affecting the weight, then alternative hypothesis that the routine is affecting the weight automatically becomes true. But in data analysis, there are chances of errors, which in case of hypothesis testing is categorized into two: type 1 error and type 2 error. Type 1 error is where one rejects the null hypothesis and, of course, obviously accepts the alternative hypothesis while lacking the evidence to reject the null hypothesis. That is, taking the previous example, I concluded that a new exercise routine is affecting the weight when actually it is not. It can happen due to several reasons like researcher bias, not taking the right amount of sample, or sample does not properly represent the population, or some factor that is not in the study is affecting the result. Type 2 error is where the opposite occurs. That is, one accepts the null hypothesis and rejects the alternative hypothesis, while the evidence to reject the null hypothesis exists. That is, I'm concluding that the new exercise routine is not affecting the weight when actually it is. It could happen if, again, the sample does not properly represent the population or the sample size is too small to show any differences. Now, which error is more dangerous, you might want to know? That depends. Here we were only talking about an exercise routine. But what if we are talking about a new economic policy or a new drug instead? If type 1 error occurs, that is, we say the drug is working when it is not, then we might prescribe the drug to people, which will not stop the illness and which might end up in death of several people. But if type 2 error occurs, then the working drug will be rejected, and so many lives that could have been saved by that drug would be lost. To avoid these errors with the hypothesis testing, one needs to conduct significance testing. Now, I'm going to discuss that in the next video. That's it for today. Thanks for watching. If you learned something from the video, then please like, share, and subscribe the channel.